So your sales can be 10% above or below your current estimate, your cost, and you create a best case scenario by assuming that positive inputs, the inputs that would increase your cash flow or NPV, sales, depreciation, salvage value, things like that. So for the best case scenario, I'm going to assume that my sales are 10% above my current estimate. Depreciation is 10% above my current estimate, so on and so forth. And the positive inputs are 10% above current estimates. And negative inputs, things like cost, are 10% below current estimates. For the worst case scenario, you do the reverse. You assume that your positive inputs, like sales, are 10% below your current estimates, and your negative inputs, like costs, are 10% above your current estimates. I mean, for the best and worst, we're not thinking, what is the absolute worst thing that could happen? If you ever did business like that, you shouldn't be in business because, really bad things can happen, but they're very low probability events. Ideally, what you would do, you create or you estimate some sort of joint probability distribution for these inputs, forecasting errors. And again, in upper level finance classes, I would do this, especially in MBA, not MBA, but MSF corporate finance class. You do something called Monte Carlo simulation. You basically create probabilistic scenarios. You make draws from that distribution, and you look at the distribution of the outcomes. But that's way too advanced, even for our next finance class, which is Finance 301. But I'm just going to mention that. If you guys want to look up what that is, ideally, you would make Monte Carlo simulation. Monte Carlo comes from the fact, why do we call that Monte Carlo simulation? What is Monte Carlo famous for? Huh? No, they're casinos. Okay. I mean, it's in the Principality of Monaco. And they have two sources of revenue. One is the casinos, the other is tourism, because it's right on southern Med. Let's do some examples of sensitivity problems with sensitivity analysis. Let's see. Here's an example. I have a project. Let me make a picture of this. In case you guys don't know, there's a little app called Snipping Tool. It basically takes a screenshot. I'm going to copy this and put it into our notes. All right, I want to know, given this base case, What effect would decrease of $1 in variable costs? Come on, man, work with me. Per unit, have on the operating cash flow. It could have asked NPV, but well, come on. Right? In this case, this is the only part that's going to change. So change in the OCF is going to be minus change in variable cost per unit times change in units is the same, actually. This is the algebraic way of doing it quickly, or alternatively, you calculate the OCF with the base case, then you increase the variable cost by $1, calculate the OCF under that number, get the difference. This is the quickest way of doing this. So that's going to be negative. In this case, change in variable cost is 1. Tax rate is 32% times. So if I increase the variable cost per unit by $1, that's going to reduce my, what you want to call, uh, operating cash flow by 1,224. If I decrease it by $1, obviously the reverse sign. You could kind of, uh, sometimes when I'm evaluating these things, this is not in the book, I kind of look at the elasticity of these things. Do you guys remember what the concept of elasticity from your econ classes? It's percentage change in something as a result of percentage change in something else. So in this case, let's calculate base OCF. I'm just going to do it on the fly. 1800, yeah, 1800 times, I sell it at 78 minus 1800 times, it cost me 57 per unit minus fixed costs of 6,400 minus depreciation of 6,500 times 0.68 plus the depreciation, 6,500. So $1 change in variable cost per unit is $1 divided by 57, right? If I remember it correctly.